Cool. Someone want to hit the lights real quick? I think it's one of the, yeah, there we go. You can keep the backlights on. Is the screen still visible with those on? Do you want, class, do you want the backlights on, off?
I mean, I'm good. I like them off, but I'm not in the back.
Off? Okay. Someone has an opinion.
We don't care what
All right. Before we get started into our main thing today, who's got questions? I may or may not be able to answer them. As I've said a couple times, populate's not. It's something that I tend to avoid, just because it's had some major issues previously. It works well now, but in the early days of Mongoose, it was pretty buggy. It didn't really work the way that it was intended to work. So I may or may not be able to answer questions that you have, but your questions, ask them at me. Yeah.
Well, my populate does not work. And then one of the errors that I'm getting is, so you can understand it, I have my two models.
Uh-huh.
Right? I got my cat model,
Uh-huh.
I have my owner model.
Uh-huh.
All right? You cannot make an owner model if you don't have a cat. It's where you own it exactly, right?
Uh-huh.
So, straight. But anyways, I don't really know how I can.
What's the error that you're getting?
The error that I'm getting, it's a 500 error for.
No, so just a generic 500.
Mongo side of it, and then when I go to my server, it's just saying that pretty much the first thing that I'm using, cat.findById is not a function.
Yeah, I'd have to take a look at your code. We'll do it. We can take a look at that tomorrow in lab.
And that's inside the first pre-owner schema.
Okay. Yeah, we can take a look at that. Any conceptual questions about Populate or MongoDB? Right. The important thing to remember is that you're actually doing two requests to MongoDB when you're running a Populate. It doesn't actually go through as one request. I think Megan was asking about that on Tuesday. If it's actually making that as one request to MongoDB, it's not. It's actually doing it in two. Mongo's really, really simple, right? It's a very simple database in the way that it stores data and the way that you can run queries against data. Where it becomes sort of less simple is when you start using the aggregate framework, which I mentioned briefly. But if you're interested in it, that Mongo University, all right, MongoDB University, is probably a good place to start. They have an entire little section on the aggregation framework. You can see here they even have a full course on the aggregation framework, right? And they have classes that are specifically for working with MongoDB and Node. So it's something kind of, if you decide you're interested in MongoDB and you want to learn more about it, this is a good place to actually do that. And it's all free until you want to sit for a test and actually get MongoDB certified, which don't bother, right? Just learn it. Certifications mean very, very little in dev work, right? It's more about what you can do, not what classes you've taken, right? It's much better to have a project that utilizes that knowledge than it is to have a certification that you know that thing. Just sort of how it works. No other questions?
Yeah, my error is real quick. Is it sending valid URL?
Yeah, we can take a look at that in lab. I guess that wasn't even a question that anyone asked. It was a question that I answered and asked myself.
When you do say it makes two requests with the populate, what do you mean?
So it's actually, say, you've already grabbed the thing that you want to run the populate on, right?
Correct.
And when you call the populate function, it actually makes a second request back to the database to find all the sub-objects for that object, right? So it's actually making another request back to your MongoD server, right? So it's not like a join is basically what I'm getting at. Like a join is a single request that we make back to SQL. We get the data from two different tables and combine it. A Mongoose populate is more like sequential than that. So you make one request, then you make a second request once that first request has completed. So if you have like a slow time to your server, right, to your database, you're kind of doubling down on that. Yeah, things that are kind of like beyond the scope of this course to really start getting like powerful use out of MongoDB are the aggregation framework and indexing. You can actually do a lot of really crazy indexing with MongoDB. Once again, that's something that if you're interested in, should take a look at the MongoDB University courses. Basically, it's a great way to optimize your database once you get your data in there, to optimize towards what are common complex queries that you're making. So, something to keep in mind, we're not using all the features of Mongoose, we're not using all the features of MongoDB. Yeah. Mongoose is less a piece of crap than it used to be. It used to really be quite awful, where half the things didn't really work in it, or were undocumented, right? We've already run into some things that are like undocumented or not well documented, and are just things that I happen to know from like beating my head against a wall for long periods of time. But it's getting better. Also something, if anyone contributes to like a large open source project, I'll give you some bonus points, like probably 10. That sounds good. If you get a PR merged into a like open source project with 1,000 followers or more, we'll set it at that level. Has to have 1,000 followers on GitHub. And I'll give you like an assignment worth of bonus points. Doesn't have to be much, right? It could actually just be improving documentation, and I'll give you bonus points for that. Just send me a link to your PR. Yeah. Like contributing to open source is a great way to like get some experience before you get an actual job. It's something you can actually put on a resume. Probably worth doing. So no real questions at the moment? What was that? Spaces all day. Yeah, 2 spaces. Okay. So today we are going to be diving into authentication. Yay, yay. This is one of those things that students find very difficult in the class. Probably up there in complexity terms and things you haven't done before, close to bitmap. So we are going to be writing an authentication system from scratch, essentially, to sort of give you an idea how these things are actually working, and so you can make decisions on what kind of authentication you would want to use. It used to be the only way to do things, right? MongoDB didn't really have a good Node didn't really have a good drop-in authentication authorization library, something like that. Ruby has a couple options, and like Python has a few options for that. Node didn't really have one, and still doesn't have a very good one. I think Passport.js is the closest thing, and it's not especially useful. It's more geared towards pulling in things like authenticating with Facebook and Twitter than it is about actually creating an authentication authorization scheme that's really easy to use. Plus, it doesn't actually give you very much. We used to teach Passport, but all we were using it for was basic auth, and basic auth is actually really easy to do yourself, which is what we're going to do today. So today we might get to the point where we are generating the tokens that we will be using to authenticate. We might not. I'm not sure yet. We'll kind of start in on this and see how it goes. So the way we're going to do this, right, is actually I should probably write this out on the whiteboard. Usually helps to write this out first. There's a lot of moving pieces to authentication, right? Oh yeah, that's great. Passport. Writing these things. well, there it is. That's close enough. Actually, I'll just do this.
Plug it.
There we go. Now there's a mouse. This is useful things to do with class time. Yeah.
He's going all the way.
There we go. Trademark Tyler Morgan. I'll also try, actually, I'm going to pull this further over so that this will show up on the recording. But now we have that lovely mouse and a home folder. Why there's even a folder on here, I don't know, because I never use it. So we'll just move that off the whiteboard. There we go. Still got our mouse, though. So, okay. So the pieces that we're going to have for this, right, is going to be our basic auth, right? I just want to write these things out. Anyone know what basic auth is? Basic HTTP auth? That's it. Yeah, let's actually start with that. So frequently you'll hear the phrase auth, right? Anyone know what those two pieces stand for? Well, so that's part of it. What was that? Yeah, authorization is one of them, and the other one's authentication, right? So we have authentication. What is authentication asking? Right? What's the ask with authentication? What are we trying to do with authentication?
Who you are, you're supposed to be.
Yeah, you are who you say you are, right? So it's who you are. Right? This most frequently takes the form of a username password, right? Not always. Sometimes there's a second step, right? A two-step verification or two-step authentication would be a good way to call that. Sometimes it's, now frequently there's things like the iPhone has like facial recognition and like fingerprint reading, which is kind of terrifying. Ideally, how you authenticate, and this kind of goes into, did I spell that right? Yeah, that is an A. I was like, why did I put two C's in that? I can't even read my own writing. So you all have absolutely no hope. The ideal sort of authentication scheme is you have something you know, and something you have. Right? Most frequently, this is the phone, right, through text messaging. But like World of Warcraft had those like USB authenticators, and like there have been all sorts of schemes to make it more so it's both something you know and something you have, right? An actual physical thing that you have, as well as a piece of knowledge, right? That's kind of an ideal authentication scheme, or the most secure authentication scheme that we currently have access to. Fun story, when quantum computing happens, everything's going to break. Like everything. It's going to be terrible. What? When it becomes more common, yes. Yep. So the other piece of this is authorization. And what's the ask on authorization?
Are you allowed to have access to what
It's what you can do, right? So frequently you'll hear these described as who you are and what you can do. Right? So this is like, are you trying to access something that only administrators can access? Right? Do you have to be logged in to create a note, right? Or murder a bear? Is that a bear you created? Right? You can only murder the bears you create. You can't murder other people's bears. So just keep that in mind. This part makes sense? Authentication versus authorization? Right? So that you'll see this abbreviated as auth, usually like this with the slash in between, and usually with more legible handwriting. This is a TH, which I made into one character. Yeah. Yeah, that's some excellent handwriting, penmanship. It's an important skill to have. It actually is. I'm gonna say this and then not do it. But when you're in an interview, like penmanship actually does count, right? If you're doing a whiteboard interview, it's like actually a thing. So you should work on it, or at least write legibly when you're in an interview, right? Take your time and actually write it so that other people can read it. I'm not going to do that, so.
Thank you.
So
you're just not going to get hired?
Yeah, exactly. Cool. Who you are, what you can do. We're going to focus primarily on authentication because it's usually the piece that's more difficult. There's a lot more technologies and moving pieces involved with authentication rather than authorization. Right? Our authorization is basically just going to be a chunk of middleware that checks if you're an admin or not. That's kind of the simplest piece of authorization. Are you an admin? Are you logged in? Are you allowed to do this? Right? The simplest form of authorization is things you're allowed to do when you're logged in, things that you're allowed to do when you're not logged in. Right? That's kind of the simplest authorization scheme. Okay. No questions right now? Okay. So the process that we're going to go through this is first we have to create a user. Right? Before we can log into a user, we have to create a user. All right, I'll just put these in steps. I'm going to put a number there. I'm probably not going to put numbers on the other ones, but there's a number one for creating a user. Creating a user is going to function the same way that we've been creating other things, right? So how are we going to create a user? Yep, we'll have a model that we create with Mongoose. And how are we going to send, once we have our server running, how are we actually going to send the user to our server? Yeah, through a post, right? We just make a post and save JSON. I know this seems like really basic, but I find it helps a lot, especially when we're tackling a topic as big as authentication, to start really basic, right? So that we're all on the same page as we go through the actual process of writing code. Yeah. So we'll probably be writing this authentication system today and Saturday, and if we need it, another day on top of that too. There's some kind of room built into the course, mostly for working with authentication because it is a big piece. So after we have a user created, right? The next process is we want to be able to sign into a user. Actually, I want to keep talking about creating the user first, because there's a step that I'm missing in this. All right. So what we're basically going to send to the user, or send to our post, is a username password. Now, an important thing when you're building APIs and websites in general is you don't want to store a plain text password anywhere in your database. Don't do it. Don't store a plain text password, right? Anyone remember like the Sony break-in that happened a handful of years ago where someone got into the Sony network and then found a text file in the intranet that was labeled passwords and had all the username passwords for every single person in the company, including the president of the company, right? Everyone remember that? Pretty much every major like hacking thing that you hear about like that comes from someone getting basic access to the internal pieces of the database and then being able to grab all the passwords out of the database or credit card information or other bits and pieces. Don't store credit card data unless you have to, right? Just as a general security precaution. It's something like you kind of have to, the way you have to think about this when you're writing an API is eventually someone's going to break into your system, right? You should approach your system as if it's guaranteed someone's going to break into it at some point, because probably someone will. If your site's popular enough, someone will break into it, right? It's just going to happen. So what you have to do is then limit the information that they can get once they get one login on your system, right, or one, even elevated user on your system, you have to contain the amount of information that they're able to access, right, through authentication and authorization. It's the reason why we do authentication and authorization. So what we have to do is we need to take that password and run it through a hashing algorithm. Right? Password. Who knows what a hash is? How many people know what encryption is? Right, yeah, so encryption, I'm going to tell you anyway, right? So encryption is the process of taking some plain text, right, that you want other people to not be able to read, and changing it so that it becomes unreadable unless you have a secret, right? Unless you have a password that gets you into it, a passphrase. That's what HTTPS does, right? If you've seen, how many people have seen HTTPS in your algorithm? Something to remember, and this is a really good point, there is no security on your website unless it's on HTTPS, right? Doesn't matter how many processes you have in place to keep that data hidden. If it's not over HTTPS, it's going to be sent in plain text in an eavesdroppable format that someone else can look at, right? So everything that needs to be secure needs to be over HTTPS. Basically, it creates an encryption tunnel between your server and someone who's using your server, right? So it's there's a process, there's a handshaking process where you establish HTTPS is a little bit weird. It uses TLS, which is the secure version of TCP, right, or a way to transfer things securely over TCP. There's a handshake process that happens where you basically agree on an encryption key, sort of. It's a good way to think about it. It's a little bit more complex than that, but that's sort of the basic thing that you do. So the difference between a hash and something that's encrypted is a hash is a one-way algorithm, right? What we're going to be using to hash is something called bcrypt. Right? So hashing, you can never get the plain text back unless you already know the plain text, right? That's the difference between a hash algorithm and an encryption algorithm. An encryption algorithm, as long as you know the secret, you can get the plain text. Right? With a hash, you have to know the plain text to get that plain text. Right?
What's the purpose of a hash?
So passwords. Right? We don't want someone to be able to get a list of passwords on our database and then be able to decrypt them and see the original plain text password. And the reason we don't want that to happen is because people reuse passwords. Right? How many people have used the same password on more than one website? Right? So you're not supposed to, but everyone does because we're human and we're not very good at memorizing random strings of characters. Right? We're not good at that.
You have to memorize so many different passwords.
Yeah. Yeah. There's still I use a password manager, right? Because I'm really terrible at remembering things. But if someone gets into that password manager, there's all my passwords, and they can see all the accounts that I have logins on. So that would be fun if that ever happens. But we don't want someone to be able to uncover passwords from our website, right? And then be able to use them to log in on our other accounts, right? So.
I guess just what's the point of storing the data if you can't look at it and know the password?
So we don't need to know what the password is, right, to be able to compare that data that we have in our database. We can never get the plain text, but if we run that same password through that same algorithm on our server, we should get the same resultant hash. Right? We're going to talk about salting when we get to it because it's a way of injecting semi-random data into our hashes because there is something called a rainbow table attack. How many people have heard of rainbow tables? Basically, you run every permutation of common passwords and collections of strings through the hashing algorithm that you're trying to hack, right? and you have a table of all the hashes. So if you see that hash, you can see what password it corresponds to. Salting helps prevent that. It's still possible to do giant rainbow tables with salting. It would probably not be worth it. You'd be better off socially engineering your target. But like we add salt or semi-random data that's specific to our server so that rainbow tables are not as effective. So what we do is when someone is going to log in, we rehash their password and compare it to the hash that we have in our server. Right? So we never know that user's password, but we can see the resultant hash of that password. If you ever have done a password recovery and got back your plain text password, stop using that website and don't use that password anywhere else, and send them an angry letter. And
Because they shouldn't be able to send them back to you.
because they should never be able to send back your plain text password to you. Right? That's a major security vulnerability and is something that contributes to making the internet a shittier place. Sorry, what was that?
When you say plain text password, you just mean the letters back to you.
Yep.
It shows me that.
Like if they send you back guest, that's the password I use on everything. Guest. Everyone's gonna start trying to log into my accounts using guest. Yeah. Guest 1234, right? Most secure password there is.
Capital G, yes.
Exclamation point. Yeah, I don't know. What was I just talking about?
The rest of your password.
Yeah. There we go. So back to how we're hashing this. We're going to be using bcrypt, which utilizes something called the blowfish cipher. If you're curious. You don't really need to know this. It's a form of AES, I believe. I think it's a play off AES, another layer on top of AES. But it uses the blowfish cipher, which is actually an encryption algorithm, right? It's actually used for encrypting data for the most part. How we make it a hashing algorithm. Oh, I should definitely not let this computer go to sleep because then it'll stop recording. Okay, still recording. That's good. How it actually hashes it is it takes characters from, or random bytes actually, from the plain text password coming in and uses that as the encryption key. Right? So normally you would have a secret and a plain text. With a hashing algorithm, you're actually, those things are both coming from the same source material. Right? So unless you already know the plain text, there's no way you can recover the plain text. Right? So you have to know the plain text to get the plain text, which is why it becomes a hashing algorithm as opposed to an encryption algorithm. Right? So far, so good? Questions right now?
So,
I may or may not be able to answer them.
so bcrypt uses a blowfish cipher?
Yep.
And a blowfish cipher, what was that again?
Yeah, it's just an encryption algorithm. I'll put it up on here. I spelled cipher wrong. Perfect. Nailed it. It's a symmetric key block cipher designed in 1993 by Bruce Schneier and included large numbers of cipher suites and encryption products. Blowfish provides a good encryption rate in software, and no effective cryptanalysis of it has been found to date. This is another important piece of software, or of software security. Right? What are the things I've already said? Things you never want to do.
Store text password.
Yeah, you never want to store a plain text password. Right? HTTPS. Right?
Anything important.
Um,
Don't store credit card.
Another big thing is don't use proprietary encryption algorithms, right? Only use open source encryption algorithms, things that you can actually see how they work. The open like if you're using like a proprietary encryption algorithm or proprietary encryption piece of software, generally what those rely on is something called security through obscurity, meaning like you can't see what's going on. People figure those out all the time. What you want are things that there is not a known bug in, right? Like a not known cryptanalysis attack, right? You want to make it so that you have to brute force the whatever cipher or encryption algorithm you're using, right? You want it to have to be brute forced if it's going to be cracked. because that makes it much more secure. Until quantum computing, and then they'll just be able to break it in an instant, and all the internet will be total garbage. It'll be fun. It'll be a fun day. Yeah. What's that?
I've never heard of quantum computing.
Yeah, it's like basically a bit can be a 1, a 0, or a 1 and a 0. Is like sort of the basics of it. They have quantum computers. They're just so huge and expensive that like it's not. They're all like research computers basically.
The original.
It's like if every byte is or every bit is a Schrodinger's cat, that's basically quantum computing. So you have to find storage for a lot of cats.
And not cats.
And not cats. Yeah. Yeah.
So, when some users save their password in Chrome when they're logging into something, when they enter that prompt, and then you can just go to settings, passwords, and review it. Or if you have like a password on your machine, it will require that before you review it. So where does Chrome keep all these passwords?
I don't actually know. I would imagine encrypted on your hard drive if they're doing it right, which I bet Google is doing it right. So encrypted somewhere on your hard drive. But the shorter answer is, I don't know.
Oh, right.
Yeah.
Was this Blowfish cipher, is that hash or encryption?
So the Blowfish cipher is actually used for encryption, right? The cipher itself is an encryption algorithm. We are using it as a hashing algorithm by using pieces of the original plain text as the encryption key, right? Rather than having a separate secret key. Yep. So, Cowabunga right now on kind of how these things work, some general security concerns. So, we get the user in, we hash the password, we then are going to actually, this password is going to be coming through in a buffer at one point, and we're going to zero out that buffer, mostly because, as I showed you when we talked about buffers, right, they allocate a random place in memory. We want to make sure we overwrite that, so we don't have a plain text password floating around on our server's memory, right? That's another major security vulnerability. Yeah.
So can you remind us again what Blowfish cipher is doing?
Yeah, so that's the encryption algorithm that bcrypt uses.
Oh, okay.
Right, and the important part about it is if you look at the wiki page, which you can only kind of read because it's partly on the projector and partly on the whiteboard, but there is no effective cryptanalysis of it. Right, this is what you want in either a hashing algorithm or an encryption algorithm, is there to be no effective cryptanalysis of whatever algorithm you're using. Right, cryptanalysis is the process of basically finding vulnerabilities in the algorithm itself and breaking them. The most common place you'll find vulnerabilities is not in the algorithm itself. Right, for most algorithms, there are a lot of mathematical proofs that have been written for that particular algorithm. Right, so you don't have to worry about the algorithm itself being broken, unless you want to use some terrible security. Where you run into issues is the actual implementation, and this is why it's important to use open source software when you're doing things like this, right? So like someone wrote a bug into the code, or there's a spot where the memory is like leaking, right? And you can get access to like passwords that way, or parts of the encryption key. Any of those things. Usually, it's in the actual implementation of the software and not in the algorithm itself. So if you use open source software, you're less likely to have a bug because there's been more eyes on it, right? And a lot of the, theoretically there's more eyes on it, and theoretically that makes things safer. That's not always true. There was a huge bug a couple years ago that a student introduced into, what was that? I think that was into TLS. I think that was in HTTPS. Anyone remember Heartbleed? The Heartbleed bug? Yeah. That's a case of the implementation being defective, right? There's something in the way that they were actually implementing it that made it so that you could get large chunks of memory off the server. Right? So it's important to use open source software because eventually those bugs get found, right? Heartbleed was eventually found, right? It took some time, and there were probably people exploiting it long before it was found, but eventually it got found, right? So you're less likely to have what's called a zero-day vulnerability, right, in the actual like software that you're using. Everyone heard the term zero-day before? It means there's no known fix, right? It's like day zero of that bug being known. Right. 0 day is sort of the worst case scenario. Is when it sort of gets published. There's no known fix, and like people are basically rushing to patch it and send up a replacement for the software you have. Cool. Cowabunga so far? We get in the username password in a post. We hash the password. We save the password. I should have written this. Save the password or save the hash to the database. And make sure password is not in memory. That says memory. I stopped writing letters at the end of that word. Just put some scribbles in there. But that last word says memory. Make sure password not in memory. Yep. Exclamation point. Right. Then we are going to eventually send back a JSON token, a JSON web token. The JSON web token is going to be something that has it's JSON, right? It has in it a hash and usually sometimes permissions. I tend to just not send them with any data, right? I put a username on them. And there's a hashing algorithm for that to verify that it hasn't been changed and that it also came from our server, right? So what we will eventually be doing is after we do these steps, we send back to whoever made the request a JWT, or JOT, as they're frequently called. All right, so the JWT is something that's hashed with, I think, SHA-15, which is a hashing algorithm. Basically, it takes what's the JSON, right, hashes it, and then compares it to what we have on our server, right? Make sense? So it's JSON data that has a hashing algorithm that uses a secret that we have on our server, right? Usually a long string of characters, randomly generated characters is how I like to do it. To make sure that one, that user's authenticated on our system, and two, that this JOT actually came from our server. Right? Remember, we don't have a client side. We can't just store something in cookies and then expect it to come back and forth from our client. So what we're instead doing is passing a JOT that can use to authenticate that user for other routes, so that they don't have to provide their username password in plain text every time they're sending some data to us.
So that token comes back as a hash and it'll match up with what our hash is. We don't know what's plain text just matches here.
Yep. I usually just store a username in it, right? And then you can look up that user in the database, or a user ID. Yep.
So when you do authentication for like GitHub repo completely through the console, you kind of make a token and then use that?
Yep.
Okay.
Very similar process. Just we're specifically using JOTs. I think they actually use a SHA hash as the token.
Okay.
And so what we're doing is based off, how many people have heard of OAuth before? Did we use OAuth in 301? I don't think we taught OAuth in 301. But basically OAuth, anytime you see like login with Facebook, login with Twitter, login with Google, that's all OAuth, right? So Google, Facebook, and Twitter are all what are called OAuth providers, right? You give them your username and password. They give you the website that you want to use that login for, a token that they can use to authenticate, right? So what this authentication system that we're going to be creating in the next couple of lectures is based off of is what it takes to be an OAuth provider, right? Just instead of getting an OAuth token, we're getting a JSON Web Token. So far, so good on the create. All right. Yeah. Step 1. That's all it takes to get through step 1. Like I said, I know this seems slow, and we're going through this step by step, and we haven't written any code. But having taught this authentication system a lot of times, it really, really helps to go through this process. Okay. So the other piece of this is when we want to log into a user. Two. Log into existing user. Yeah, that's semi-legible.
Like you want us to hire a new time.
So when we log into an existing user, we're going to use to send the username password to our server basic HTTP. And you've already been using basic HTTP a lot. You probably didn't realize it though. All right, so this goes to the server. The basic HTTP is anytime we did like username : password at a domain, right? That's basic HTTP. Basically, the format is there's a header. Headers of authorization, because that's originally what this was used for. Right. Something you'll notice a lot with just internet things in general is that a lot of these things are getting used for not their original design, right? Like HTTP and JavaScript were never designed to build like fully functioning applications, right? HTML was originally just to like have a format to read like research documents in, right? That's what it was originally designed for, and we obviously use it for many more things now. How many people have read a research document in HTML? You know, like 1 or 2 people. So we have headers, right? We have the header authorization, right? And what that's going to be set to is a value of basic, right? So the string basic, a space, which I'm just going to signify with a little spacey deal. And then base64 encoded username : password. Right. So that's what goes into basic HTTP, right? That's how it gets sent across anywhere that you're using it for HTTP, right? It's a header with authorization, basic, and then base64 encoded username and password. So important things to remember about this: it won't look like plain text, but it is plain text, right? Like how easy is it to convert using a node buffer base64 to plain text? Pretty easy, right? Like you just do toString, right? So that's why this doesn't get used as like an authentication scheme, right? It's not something you want to send with every single request being made to your server. It's something you want to send once and get a more secure format. Cowbunga? So we, sorry, I didn't mean to interrupt.
This
Question?
is for logging in, so when they put in their password, it gets turned into, it's hashed. 64.
Yeah, so after this comes in this format with authorization equal to basic _ base64 username password, right? What we're going to do.
Basic being the username, basic.
No, basic is just a string in there.
Oh.
You just have to have that string, and that's signifying that we're using the basic HTTP version of authorization. There's some other options that you can use for authorization. Right? Later, we'll be using a bearer and then have the jot after that. Right? Not to be confused with bear. We'll have bearers and bears, and it'll be super fun for me. So just be prepared for that.
Prepared?
What?
Prepared?
Yeah, be prepared for bearer.
Prepared.
I actually probably won't use the bears because that will just get confusing and annoying. So after this comes into our server, right? We look for the user with username, right? We parse the basic HTTP. We'll do this in a middleware that we write ourselves. This is the piece that we used to use Passport for, but it's super easy to write ourselves, so we're just going to write it ourselves. It'll also give you a look at a piece of actually good, like, functioning middleware, right? That's useful and not just like for a demonstration. Yeah. Thank you. Yeah. So we parse the basic HTTP, right? We find the user corresponding to username. Find user NDP. We then hash the password coming in. Hash incoming password. And then compare it to the database for that user. Right? So, request for login comes in a basic HTTP format, right? Probably GET request, doesn't necessarily have to be. I usually do GET request. I do post to create and GET to sign in. That's just how I build APIs. That's pretty standard. You'll see that in a lot of places. But feel free to do it however you want, right? Make a delete request to sign in. That could be fun. Don't actually do that. We parse the basic HTTP data, right, which should give us a username and a password. We find that user in the database, right? We hash the incoming password, the password we got from basic HTTP. We then compare that resulting hash to the hash in our database that we have for the user that we found. Right, so these are kind of all the failure points for a login, right? We could have badly formatted basic HTTP, right? We could not find the user in the database. We could not have the password, our hashed password, match what we have in our database, right? Those are kind of the three big failure points. And we could just have a general database error, a general server error. So once this is all complete, we do the same thing and send back a JOT. Question?
I was going to ask, didn't we send them the JOT to start with? Did that not get passed back in?
Yeah, so that will go back, right, when you first create the user. But if you restart the app, right, or that JOT goes away, or the JOT expires, you have to have a way to sign in to an existing user. That's it. Simple, right? Like I said, there's a lot of moving pieces today. We'll try to get through up to the point where we're ready to generate JOTs, and we might even be able to generate a JOT today. We'll see how that goes. Depends on how long this is going to take. But breaking down the pieces into small bits like this should hopefully help, right? Breaking down the process. Because it's all the functions that we're writing are not very complex, right? It's going to be pretty simple things. We're going to be utilizing a lot of libraries already written for us. The difficult part is keeping track of all the different moving pieces, right? So the kind of the moving pieces are going to be our user model, right, which is going to be utilizing bcrypt, which is a module that we're going to pull in, right, a library we're going to pull in to hash passwords. Right, we're going to have our basic HTTP processing middleware. We're going to have something that generates a JOT, and then we're going to have something that verifies that that JOT came from our server. Cowabunga? Questions on the process? Right, on any of these steps, either the creation of a user or the sign in to a user.
When we're parsing the basic HTTP request,
Uh-huh.
that's when we go in there while it's in the base64, right? And then turn it into, I guess for our username, it would just be plain text.
Mm-hmm.
And then for the password, it would be hashed.
So we pull in the plain text password from the basic HTTP, right?
Right.
And then we hash that, yes, and then compare it to what's in the database. Yep. So things that we're going to have to do when we write this piece of middleware is we're going to have to make sure, one, what we're going to be using to convert from base 64 to plain text is a buffer, right? What we need to make sure is that that buffer gets zeroed out so that memory isn't sitting someplace on our server, right? We don't want to have that be basically anywhere that someone could potentially get access to. Right. Questions? Your questions. Ask them at me.
Well, if you reset a password somewhere, they send you a link to reset it.
Yeah.
And then you fill that in. What does that process do?
So what that process would do, if we were going to implement that here, right, is it would take that new password. One, it should generate a random hash for the URL, right? That random hash in the URL corresponds to an entry in the database. And then what we do is have that new password, hash it, and store it in place of the old password. Right? So you should never be able to recover your old password, basically, from any website. If you're using a website where you can recover your old password, stop using that website. Right? It's really terrible security. You want to be able to replace your password in case you forget it, right? Because humans are bad at remembering random strings of characters. So it's not an uncommon occurrence for you to forget your password, right? Oh, really? There you go. There's some places where you don't want that ability, right? Things that are really, really high security, you don't really want the ability to reset your password. Also, like things like security questions are the dumbest thing in the world because you never remember them, and they also are, if you answer them honestly, it's shit that people can find out about you in, about 2 hours of like internet research. Yeah. Anyway. Yeah, so it's just basically replacing the hash in the database. That's the process.
I forgot password. It says, well, your password is this.
Yeah.
Oh, thanks.
Yeah, that'd be great. Really secure. Right? So once again, with the creation, username password comes in, we hash the password, save it to the database, send back a jot. Right? Sign-in happens. We grab the data out of the authorization with BASIC and base64 encoded username password. We find that user in the database. We then compare the hash that we have in the database for that user with the hashed password that we got, or with the password that we got out of the basic HTTP, then send back a jot. All right? When someone sends in a jot, we see if that jot came from our server. We find the user in the database that corresponds to the ID inside of it and see if they have access to what they're trying to access. Cowabunga on those processes? Yeah. Okay, cool. I've been up here talking for a lot, so now's a good time for a break. We'll start again at when this clock says 1940.